So today's video is just a review of writing formulas for binary ionic compounds. And I've also thrown in some of our compounds that will contain our polyatomic ions as well. So in class we learned that to write a formula for an ionic compound, you put your symbols side by side, you label your charges, and then you crisscross your charges. Then of course you want to check it and make sure that the overall charge is neutral. So just to review, in class we did aluminum oxide. So you put Al and O. You can tell from the name that aluminum and oxygen are in the formula. And then you label your charge +3, -2. Now those charges come from, if you look at your periodic table, aluminum is in group 3A, and everybody in this family always forms a +3 charge. And then oxygen is in group 6A. Everybody in his family forms a -2 charge when they form their ion. Now the next thing you want to do is crisscross your charge values. That means just the numbers. The 2 and the 3 come down. So the correct ratio is going to be Al2O3. And that will be how you write your final formula. You only have symbols and subscripts in the formula. The way you interpret this is there are 2 aluminum ions, so it would be Al +3, Al +3, and there are 3 oxide ions, O-2, O-2, O-2. Now notice, if you were to determine the overall charge, it has to be neutral, because if you take a look here, +3 and +3 gives you overall +6 charge from both of the aluminums, and 2, 4, 6 is a -6, and +6 and -6 does equal 0. So your formulas, your compounds are neutral. Now let's look at calcium hydroxide. Now this might be a little confusing at first because we're just learning about our polyatomic ions. Hydroxide is one of our 22 polyatomic ions, so you have to recognize him. Let's put our symbols side by side. Calcium is Ca. Hydroxide, remember to put your polyatomics in parentheses. That helps us identify them for now anyway, while we're just learning how to work with them. So OH is the formula for hydroxide. Now we're going to label our charges. Calcium is a +2 because he's in group 2A. Now hydroxide, you have to memorize his charge. He's a -1. You still crisscross your charge values the same way. This 1 comes down to the calcium, and the 2 comes down as a subscript outside of the hydroxide. So your answer will be Ca, OH is in parentheses, and a 2 outside the parentheses. Remember, the 1 is understood, so you do not have to write it. Let's look at number 3, potassium iodide. Put your symbols side by side, K and I. Label your charges. Potassium is +1 because he's in group 1A. Iodide's a -1 because he's in group 7A. Notice these charges already cancel, which means the formula is already in its proper ratio. So the answer will be Ki. And again, the 1s are understood. Barium oxide. You're going to put Ba and O side by side, and we're going to label our charges. Barium is a +2 because he's in group 2A. Oxygen is in the 6A family. They're always going to be a -2. Now, notice if you crisscross your charges, you get a 2 and a 2. Both of these are divisible by 2, so you would need to reduce this formula. Divide by 2, divide by 2. That becomes a 1 and a 1. So your formula is BaO. It's a 1-to-1 ratio. Now, with this formula, you could have recognized that it would reduce from here. Notice the +2 and the -2 already equal 0, which means it's in the proper ratio, a 1-to-1 proportion. Potassium nitride, K and N. Potassium is a +1, nitrogen is a -3. Again, we know that because we look at our periodic table. Potassium is in group 1A, they're all a +1. Nitrogen is in group 5A, they're all a -3 charge. Crisscross your charge values. A 3 comes down and a 1 comes down. So your formula is K3N, and that is your answer. The last one, magnesium phosphate. Put your symbols side by side, Mg. and put a parentheses around phosphate, PO4. He's a polyatomic ion. Again, you have to memorize your polyatomic ions, but a lot of them do end in ate or ite. That's one way that will help you recognize them. Magnesium has a +2 charge. Phosphate's a -3 charge. So when you crisscross your charge values, you get Mg3, PO4, 2. So your final answer, you cannot reduce that. They're not divisible. So your answer will be Mg3, PO4, 2. And you would want to leave your polyatomic ion in parentheses. Okay, so that's it. Now you should be good to go to do your homework.